This video, we're going to prove that if G is a P group, then the center of G is non-trivial. If you like watching mathematical proofs like this, consider subscribing to my channel. That's what we do here. Now, what does it mean for G to be a P group? All it means is that the order of G is P to some power, and P is prime. Okay, so now let's look at the class equation. The order of G is going to be P to some prime, where n is at least 1. Because if n is 0, P to the 0 is 1, and that's not a prime. 1 is not prime. And of course, n is an integer. Now, we have that the order of G is the order of the center of G plus the order of, say, the class of C of x1. These classes that I'm about to write, their magnitude is going to be more than 1. The center is their set of all classes that have exactly one element. These classes that I'm about to write from here on, they have 2 or more elements in each class. So we have the class of C of x2 plus the order of C of xn. Okay, note that the class, not the order, note that the class of xi is a subgroup in G. And this is for all I. 1, 2, up to n. Okay. But that implies that by Lagrange's theorem that the class of xi must divide the order of G, which is P squared. Their divisors of P squared lie in this set. 1 P squared. Okay, recall that the order of C of xi is not equal to 1 for all I from 1 to n. If their order was 1, then they'd be in the center. Okay, so we know that their divisor, the order of C of xi must be either P or P squared, because it's not 1. Okay, it's not 1. This here must divide P squared. So either it's 1 P or P squared, but it's not 1 by definition of the length of the class. Okay, so what we know is that the order of the class of each class must be at least P. So what does that tell us? So the order, so P divides the order of the class of C of xi for all I 1 to n, because the order of any class is either P or P squared. Okay, so what we have is the following. We know that the order of G is equal to the order of the center of G plus the order of the larger classes, C of xi, all the way down to C of xn. Solving for this, we have that the order of the center of G is the length of G minus all of this. Class of C of xi, the order of that, all the way down to the order of C of xn. Since P divides the order of G, which is P squared, and P divides the order of each of the classes for all I from 1 to n, this implies that P divides all of this. Let's see if I can copy and paste. Let's try it one last time. Okay, so P divides, not going to rewrite it, but P divides that. But that implies that P divides the center, the order of the center of G. But P is at least 2. This implies that the order of the center of G is at least 2, which implies that the order of the center of G is not 1, which implies that Z of G is not, well, let's write it this way. Z of G is not equal to the set that is E, because that's, if the center must be in G. Let's try that again. E must be in the center, because the entry fee to be in the center is that you commute with every element in G. And of course, if G is any element, if little g is any element in the group G, it clearly commutes with E, putting E into the center. But the center is not only G, so that implies that Z of G is non-trivial. Of course, for the center of G to be trivial, the center of G would have to be E. But we just proved that it isn't E, hence it is non-trivial, and that's what we wanted to show. So in particular, if G is a P group, that means G is has P as their divisor, then the center will be non-trivial. If you like watching videos like this, subscribe to my channel. See you guys in the next video. Leave a comment. Friends and family should be informed about my channel. Get back at your friends by letting them know about my channel. Watch and learn.